Hi class, this is Bill Berry here with another series from our IT 102 Introduction to Programming with JavaScript. This series is on programming with repetition, also called iteration or looping. We're going to learn this week another key control structure, a key tool that we need in our toolbox in order to write JavaScript programs that address any kind of real-world problems. In the past, we haven't really done interesting things with multiple pieces of data. We've sort of stayed very tied to one piece of data at a time, but we're going to be able to do multiple things now with looping, and that's going to be really useful. So let's jump in and look at what some of the topics are going to be this week. First, we're going to talk about why looping is useful, all right, and what sort of scenarios do you use it. We're going to do plenty of practice or offer it, and if you're in class with me, of course, we'll do a lot of that practice in the room together. We're also going to look at different kinds of loops, while loops and for loops, and how really in the end they're not that different. We're also going to talk about interesting things that you can do with loops, so give you some examples of how loops can construct interesting things when you combine it with some other simple stuff. And so we're going to have a good number of examples to work through to really lock in this knowledge of how loops work. So the first thing we're going to do, just talk briefly about why we want to repeat certain code. We don't want to write the same code over and over and over. What we'd like to do is say, hey, I just want to run this same code multiple times, right? If you want to input 5 employees worth of data, you really don't want to have one prompt statement for employee 1, one prompt statement for employee 2, one for employee 3, one for employee 4, one for employee, like, you just can't keep going, because what if it's 100? You're going to write 100 prompt statements? Then how are you going to add all those things together to get an average or a sum or things like that? It's going to be completely impossible to manage that. But with a loop, we can do that stuff, because what we're really doing is inputting one piece of data 100 times. So looping is really going to open up a new world in terms of the size of the projects that we can work on. The other important thing to note is you do have to tell the language that you want to repeat something, right? You want to keep circling around and repeating certain code, but it's really important to tell it when to stop, right? Because you don't want this stuff to execute infinitely, right? Eventually you want to get out in some orderly fashion. So both of those things are really important. So below you can read a few examples of things that would be real-world examples of what you'd need to repeat. Keep entering a bunch of employees. Keep processing form fields one at a time, writing out numbers in a certain range. Guessing games and number games and dice games and card games are great ways to practice this stuff. So we could write, and we will write, a little guess the number game, right? We can also have a card game, let's say, where you have 4 players and 3 cards, so you need to keep dealing cards to each player. Those sort of have a looping or repetitive nature to them. And multiplication table is another great example. So many scripts that we write are going to require repeated code. All right, so first thing we're going to do is look at while loops. While loops are a super basic type of loop that you can use in any scenario. So if you do learn other scenarios later, other kinds of loops, that's great, but you can use a while loop for anything. And some languages really only offer a very basic kind like this. Usually there's a couple, but a while loop will get you a long way. While loops will run 0 or more times, right? And they are controlled by a condition. So there's something that tells them to stop. That's the condition. So the analogy here from our little robot is that you might want him to reach the wall. The goal might be to get the robot to the wall. So you have him outstretch, move, put his hands out so his fingertip sensors are pointing in the forward direction. And you might say to the robot, while you aren't sensing the wall, keep taking steps. So what's going to happen is the robot's going to check his sensors. If he doesn't feel anything, he's going to walk forward and check his sensors and walk forward, etc. And that loop is going to get him all the way to the wall. Simple piece of code. Notice you don't have to say to the robot, take 1 step, take 5 steps, take 83 steps. Doesn't matter. He's just going to keep going until he senses the wall, right? So that's an easy way to consider, to think about a while loop. Notice that it can be 0 or more times. So this is an important thing. Let's say that you position the robot so that his fingertips are already touching the wall. If that's the case, is he going to fall over? Is he going to take a step and fall? Well, no, because you've said while you aren't yet sensing the wall. If the sensors are already activated, he doesn't take 1 step to begin with. The loop never actually runs, right? He checks, he knows he's already there, and he doesn't take any steps. So the while loop works in any of these cases. Let's take a look at what the algorithms look like in flowchart and pseudocode. So here's an example of that with our robot. You got the start and end. You ask the robot, hey, do you sense the wall yet? Right, the robot checks to see whether he is sensing the wall. If the answer is yes, he's done. Right, he's done and go to the end. Right, if he's not, you take a step. Right, if the no case, not sensing the wall, take a step, go back, check again. Take a step, go back, check again. Eventually he's going to be touching the wall and the answer is going to be yes, and he's done. So a very simple kind of construction. Flowchart's a good way to see that. You can also do this in pseudocode where you say while not sensing the wall, and then you use indentation to indicate all the things you want the robot to do within that iteration, that loop. And then you know that once you get out of the indentation, once you're out of the while loop, you know that the robot is now at the wall. Wherever he started, he's now there. He's touched something and he's at that stopping point. So that's great. Let's look specifically at how these things work in code. The while loop is going to require a continuation condition in parentheses. So just like when you write an if statement, you automatically put parentheses and you open and close curly braces, you're going to do the same thing with a while. You're going to say while, open, close, and then you're going to put curly braces. And then inside the curly braces, you're going to put all the code that you want to have happen for that iteration. Right? Simple enough. Now, in this case, you're going to put a condition in here. So just like you did with an if statement, but this is now the loop continuation. This is, I want to keep going while the fingertip sensor reading is false. While there is no fingertip sensor reading, keep taking steps. So that's what this might look like in our sort of moving the robot code into something a little more JavaScript-like. The one important thing that you need to think about when you write these while loops is you must make progress toward the goal inside the loop. If we didn't have something in here that took a step, you'll notice that we could never reach the wall, therefore the sensor reading could never get to be true, therefore this loop would run infinitely. Another way to think about that with the robot is like if the robot is on ice and when he tries to take a step, he doesn't actually step forward. He's just going to run until his battery dies, right? He's going to be in a sort of an infinite loop or more or less infinite loop. So you really need to make sure that you're making progress inside the loop toward completing, toward making this condition true that is controlling the loop. So that's super important stuff. So let's move forward with another while example. Here's a great example of how to use this stuff. So in this case, we're going to use a thing that I'll call priming the pump, where we're going to ask a question or set some sort of value outside the loop that guarantees that you get into the loop, and then you can keep looping once you're there. So in this case, we just want to have a guessing game, right? We want to say, hey, we're going to pick a random number and store it in a variable called secret num. Now this is going to use the math.random function. That's a method actually. That method is going to generate a number between 0 and not quite 1. It's going to multiply it by 5. It's going to do math.floor, which is going to move that down to the next lower integer, and then you've got to add 1 to get back up to the number between 1 and 5, right? So this code right here is something that you'll want to copy and pay attention that that's something that anytime you want to generate a number, a random number between 1 and something, you can put that something here and you can use this code. Then you ask, hey, guess the number, right? You've picked a secret number, but you haven't shown it to them. Then you say to the user, hey, guess a number. And then you store that in a variable called guess. And then you want to continue to loop while the user's guess is not equal to the secret number. Right? So you're going to keep looping until they guess it correctly. And the way to make progress toward that is you got to let them guess again, right? So in here, notice it's very similar to the prompt that we had up here, but in here you know that you haven't guessed correctly, right? Because if you had guessed correctly, it wouldn't do this code at all. It would just jump out here and be done, right? Because this would already be true. But if they haven't guessed it, you ask them again and say, nope, it wasn't it. Try to guess again. Now, eventually, they're going to get tired. There's only so many numbers between 1 and 5, so eventually they're going to guess it. Once they guess it, then this becomes, right? This part is going to become false. So guess is not equal to secret number. No, guess is now equal to secret number. So as soon as this becomes false, this is going to then jump out, You're going to process after the end of the curly brace, and then you know that by this point they guessed it and they are out here, right? So as soon as this loop condition becomes false, it's going to jump out. So that's a great example of a while. Now, this is simple. We're going to keep doing more examples with both whiles and other types of loops, but I'll introduce one thing real quick, and that is there's a challenge that you might want to take on, and that is if you want to combine iteration with selection, take this same code and then try to add the piece where their guess is too high or too low. Right? So you don't just say guess again, you can say the guess is too high or low. That way you could actually put a much larger number in here, right? Because they could do, by process of binary elimination, they could actually guess a number between 1 and 1,000 even, or 1 and 100 certainly, if you're telling them whether they're too high or too low. So where would you do that? How would you implement that? Stop and think. Remember, programming is more about thinking than about typing, so stop and think about that before you move forward. The main question is, where does this code go? Where exactly do you need to put that? So you need to think about that carefully and say, where exactly do I have hold of the thing so that I can ask the question in the code, did they guess it? Is it too high? Is it too low? And I think if you think about it for a second, pause the video if you want to ponder it a sec. The place that you have to put it is going to be right here. Right? You're going to actually replace this, because you're not going to say nope, guess again. You're going to simply say it's too high or too low. So you're going to get rid of this and you're going to replace it with an if statement, and there's going to be an if part and an else part, and the if part's going to be if it's too high, the else part's going to be if it's too low. So you'll be able to work through that. Notice though, you don't actually have to worry about the logic where it is equal to, because if it's equal to, you wouldn't have gotten here, you'd kind of be okay. So if you think about it, you might be able to work through that and make the code fairly straightforward. But you definitely want to check, if you write that code, check the cases where guess is equal to the secret number, guess is lower than the secret number, guess is higher than the secret number. You have to think about it to make sure that you've covered those cases and test it. Again, if you're in class with me, we'll work through this in class and talk about the ins and outs of it. So this video is long enough. We're going to stop here, but in the next video we're going to start talking about for loops. There's another type of loop that's important. Most languages offer both a while kind of loop and a for kind of loop. There may be special names for those, but typically those words are very typical across languages. And so we're going to talk about for loops and why we care about those and why they can help us sort of make shortcuts out of some of our work. So thanks for watching this video, and look forward to seeing you in the next one. Thanks.